can't hear me. Okay. Thanks for joining us the third day of the show, last day of the show. You must be exhausted. I know he is. But he won an award. In fact, today's panel is supposed to be all the award winners from last night. We were delighted to give out the awards for the fourth year in a row, and I want to congratulate you for winning the awards. Unfortunately, everyone forgot to tell the award winners that they had to show up at 9 o'clock on Thursday, so we don't have all the award winners. In fact, Zifra is supposed to join us, and if they're in the room, please do. And if they're not here, well, tough. Eric Lemonnier from, thank you.
No, he's working with me.
Yeah.
Working with me. It's not Zifra.
Eric Lemonnier from Eiffage couldn't join us, won't be with us, and Zifra looks like won't be with us either. But there's still an opportunity to hear from two winners from last night about how their choices were made. We're going to have a short session to talk about winning the awards. Excuse me, I lost my voice. If anyone sees it out there, please let me know. You have no sense of humor this morning.
It's early.
Maybe I'm not funny. Thank you for not saying so. First I'll let each of them introduce themselves and explain the award that they won and why they think they won it.
Great, thank you very much. So my name is Menno van Rijn. I'm from GST Technologies, GST IT Consulting. Probably you will have seen the remotely controlled cars on the stand. That was the demo that we won the Testbed award for. I must say we're still in shock, in positive shock, about the fact that we won.
You knew there was an opportunity. You were a finalist at least.
Definitely, yes. But there are a lot of good testbeds out there.
Yes.
So on the one hand, the remotely controlled car part is fun, but on the other hand, there's a whole data architecture behind it. So it's really trying to show, I think, also the spirit of this event, the use of IoT, the data behind it, and how you can process that data. In this case, we apply it to remotely controlled cars. But
I think it's worth pointing out that it's about the car, not the IoT that goes into the car. That's very much in what we're trying to show this week is using the technology to solve real problems in the real world.
Exactly. And that's, I think, what we, of course, haven't heard exactly why we won the showcase award in this case.
Because you paid the check, you didn't remember?
I forgot about that. I tried to remove those kind of memories. No, but we imagine that it must be indeed partially because it is indeed a cool showcase to play with, but there's a serious message behind it. Indeed, it's not purely about IoT. It's actually about empowering the data behind it. In this case, we applied it to a use case which is insurance, that you can take that kind of data out of the car and calculate how good or bad somebody's driving. But there are, of course, a lot of other cases inside the connected car world, but even outside.
Sure. Joel, short introduction?
Okay, hi everybody. My name is Joël Rubineau. I'm French. I live in Paris, and I'm CEO of Cartesian. And we won the award because, yes, we sent you the check, and because also we believe that we have a very cool technology. We specialize in artificial intelligence. I don't like artificial intelligence. I like machine learning, but we specialize in, let's say, machine learning at the edge. And we started the company 4 years ago with an idea, which was instead of sending all the data to the cloud, why don't we send intelligence to the edge, to the IoT? For many good reasons. First, because of latency. You can decide directly at the edge. For security reason, for power control. I mean, many reasons it makes sense to have intelligence in the edge. But then we looked at this environment, and we believe that today the physical world and the digital world are merging, and the point of intersection is microcontroller. Microcontroller is a piece of hardware that is today present in every single IoT. 15 billion microcontrollers are sold every year, which means 500 every second, so it's a lot. And we believe that if we could develop a machine learning engine that is able to run inside a microcontroller, then we'll bring a very innovative solution on the market. And so we look at the market of artificial intelligence framework. There are many, like TensorFlow, like Café, and so on. And they are all very powerful, but they all run in the server. They all need to have a lot of power, a lot of energy, but they are very powerful. And none of them can run on a microcontroller. So we hired a bunch of PhDs in advanced mathematics, machine learning, signal processing, and so on and so forth. And we started to rewrite from the algebra, so from the mathematics, to rewrite every single algorithm, machine learning algorithm, signal processing algorithm, so they can run inside a microcontroller. That was 3 years of work.
I have to ask, is the implication therefore that you should always run the machine learning at the edge? Always?
Yeah.
All applications?
Yeah. So I don't know if we can have some, let's say, sound back to the stage, because I have some difficulties to hear my colleagues. So I don't know if in the background over there
Bad
I can
question,
send it.
anyway. No,
Say it again,
the
please.
question is, should you always run your machine learning at the edge then?
Run the machine learning at the edge? Yes, because today machine learning is a very, let's say, vague term. It means anybody is saying, I'm doing machine learning at the edge. Well, when you talk machine learning, you have to differentiate between two different tasks. The first one is to learn. The second one is to do the inference, meaning the analysis. So doing the analysis at the edge in a microcontroller, no big deal. A lot of companies are doing that. Learning in a microcontroller, I don't want to be arrogant, but we are the only one today to be able to do that. And by the way, the Gartner just published over the July their hype cycle, and they identified Edge AI as a very...
But then my question is there an opportunity, is there a reason to do machine learning in the cloud instead of on the edge?
It's a lot of reasons to do that, a lot of
I would
very
think so.
valid reasons. I'm going to show you one. It's called Bob Assistant. And this is why we won the award, actually. It's because we've put machine learning inside this box, learning and inference. So the way it works is very easily. Hello, how was the breakfast? Good? Thank you. Welcome. Congrats for yesterday. Yeah, so from a business perspective, doing machine learning in this box is really a breakthrough innovation, because you just put Bob, his name is Bob Assistant, on any machine. It could be a small pump, it could be a big air conditioning system. Enter, push this key, then it starts to learn locally and do the learning inside the microcontroller, create the model inside the microcontroller, and then after a while it will switch to inference, and it will say, okay, continue to learn and to listen, to the vibrations, for example.
But the question is, why not do some of the learning in the cloud, and then
But to do the learning in the cloud, you need to have the data, and you need to have the data scientists.
Sure.
And none of the companies have that. It's very difficult to get relevant data, because there are tons of data, but relevant data, very difficult to get. I was working with a company in Korea. They want to have an intelligent fridge in order to detect when the vegetables are degrading. So they have to buy vegetables from all over the world to put that in a lab with sensors to capture the degradation of the vegetables and the papaya and the bananas and of the world, just to create the model. It's just impossible. And so first, getting the data is a challenge in the cloud. Second, you need to have data scientists. Data scientists, when they are just out of school, they get $180,000 just out of school. The best are working for Facebook, Google, and Airbnb. So companies have a lot of difficulties to hire them. When they hire them, they put them on financial services and things like that. So it's difficult to have.
Sometimes you're integrating data from multiple controllers. So for example, my Mexican car, made in Salinas, Mexico, made by Ford in Salinas, Mexico, has 82 ECUs. Each one is a microcontroller.
Yeah.
And you want to learn from multiple ones at once. Does it make sense to do the learning then at the edge in that case?
that's. I'm not saying that learning in the edge is going to solve everything, and I'm not saying that the edge is against cloud.
Right.
I think they are very complementary. It depends of the use case. In some use case, it makes more sense to do that at the edge because you don't need many data. You want to have to work on the latency and things like that. In other case, if you want to do not detection but qualifications of problem, then you need to go to the cloud. So from a business perspective, you need to think first.
Stop asking questions. That was the answer I was looking for. Our last winner this morning from Zifra.
Yes.
But can you tell us a little bit about yourself and your winning entry into the competition, and where you drank last night?
Okay.
No,
My name
not
is
the last
Ria.
part.
My name is Ria. I'm the business development manager in Zifra, and here in Barcelona we actually applied a few projects. If I'm not mistaken, we even submitted 3 projects, but two projects were shortlisted for the nomination. One of them was our implementation of machine data collection system in the Godrej and Boyce in India, and the second one, the winner is autonomous trucks for SOEC. SOEC is the 5th largest coal miner in the world. They have a huge variety of products from Zifra until now. It's a fleet management system, safety system, and other digital products for a digital mine. And since the last year, they started to implement the cutting-edge technologies, fully autonomous trucks. The project is started November last year, if I'm not mistaken, and until now, they have 2 trucks, and we hope that they will have more. And speaking about trucks, it's really sophisticated technologies, meaning that it's a 130-ton machine that is running around quarry, fully autonomous, no person, there is no driver inside like in Tesla or something. One of the key points of the project and during the launch was to provide 100%, 110% autonomous trucks, meaning that even operators shall not be present inside the driver cabin.
So the obvious question: are we talking about a GPS fenced area, or are they driving on the open roads?
It's open pit, so they have communications.
But it's geofenced. It's in a certain area, not on the open roads. There's a big difference between level 5 on the open roads, on the open highways, and level 5 in an open pit.
Of course, yes, of course. That's the first reserved locations is the first where autonomous vehicles will be implemented, because there are much less harm for people, for the surrounding, and what is the most important for autonomous vehicles, the most dangerous part is the vehicles with drivers inside. They are much less predictable than robots that are going around defined trajectories that are very well optimized. And so that's how we penetrated this market, and we believe this will be the first and the biggest growth in this area for the next 5-10 years. And maybe then later there will be implementation of autonomous cars in the cities, etc.
That's a very different problem.
Yes, it's
Has the accident rate actually decreased in the pits? Has the accident rate come down in the pits? I mean,
of course, yes.
Did you record the number that was when there were human drivers compared to the number of robot drivers?
Not yet. To that extent, we haven't reached yet, because there is a still pilot project. It's 2 trucks that are going, and of course the passes for them are predefined, optimized, and people know where there are robots.
Right.
So it's not yet full implementation with 20 trucks, and there might be people occasionally appearing somewhere. So this is still pre-production stage.
Okay, I've got some more questions about how they chose technology, how they chose systems integration, and so forth. But this is your opportunity to ask questions. If there's a microphone somewhere. Sham, go ahead and yell. I'll repeat it.
come up? How do you combine the models to make better intelligence across the fleet of refrigerators?
This is why I was asking about cloud intelligence, cloud learning, because there are opportunities where there are multiple GPUs, multiple ECUs, multiple microcontrollers.
So just to repeat the beginning of the question is in the example of the refrigerator, all refrigerators are different. So the learning is going to be different by refrigerator, and so what is the advantage of doing that at the edge versus the cloud, right? So the real question you have behind your question, if I understand correctly, is how do we get the learning in each refrigerator to go to the cloud to increase the learning there? The point is, in that case, we reversed the problem with this company. We said, instead of learning each vegetable, we are going to learn an empty refrigerator. And we learn the refrigerator when it's empty, and so if something is going wrong inside, then we'll tell them in the box number 3 there is a problem. And then you open, we won't be able to say it's a banana or it's a salad or whatever, but we can tell you there is something wrong in box number 3. So to do that, it took us a week. For them, they have been working on the model for 3 years, and still they are not successful, because they don't want to say there is a problem, they want to say the banana is a problem, or the salad is a problem. So if you want to do qualification again, it's very painful. You have to go to the cloud, and you have to go to servers and NVIDIA cards and a lot of power and create the model and so on. If you do it at the edge, you have to adopt a different strategy, learning locally. And the beauty of learning locally is could be an advantage. It could be a disadvantage in this case if you want to identify. Of course, you cannot do it because you need to label each and every data. But if you want to learn in the edge, for example, in this case of Bob, it's the same Bob, whether we are on a small pump, or on a big air conditioning system, or another system. Whether the pump is on a piece of wood or a piece of concrete, whether it's horizontal, vertical, whatever the situation, we are going to learn locally. And therefore, this will become the gauge, this will become the reference. So when you install a pump, you don't know whether this pump is going to be, where the pump is going to be, in which environment. So if you have to anticipate that in the cloud with a model, it's very painful. And again, remember, you don't have data scientists to do that. The fact you can do it at the edge, and the learning is done inside the microcontroller, you don't have to prepare a pre-trained neural network model or any model. The creation of the model is going to be done autonomously inside Bob, in that case. So it will learn locally. It will say, okay, that's my environment. And starting from there, I switch into analytics, and I'm going constantly, every, for example, 1 hour, 1 day, whatever, to capture the data, look at the data and say, okay, this data, when I compare with my learning, it's in the learning, so the machine is doing good. If it's outside, the machine is not doing good. Then I connect to LoRa, and I send a signal. This device now is sold in France, basically all in Europe, and now we start the US. It's with Airbus, it's with Air Liquide, with Veolia, with SNCF, many large companies in France. They've been able to deploy predictive maintenance Industry 4.0 in 1 day, versus, let's say, a lot of time if you want to go the traditional way, meaning that you have sensors, you capture the data, send the data to the cloud, do a model, do the analytics, and so on and so forth. So if you want to have a platform, it takes forever. Here you can do, so it's not doing everything, but at least to check whether your machine is in good condition or not, and send an alert to the person responsible for predictive maintenance, you can be up and running in less than a day. So again, I'm not saying that edge is the answer versus cloud. I think today the cloud machine learning war is won. We know the winners, the Google and Facebook and so on. I think we are starting the war on machine learning at the edge. And today, there are no winners, a lot of competition, very exciting time, But that's the new playground for companies to play,
Well,
because
we have
they are
we do have 4 winners.
so we are very happy to have received this award. Last week we got an award in San Diego at MEMS and Sensor Congress Expo, same best technology of the Congress. So we are in that war. We have some bullets, some weapons, and some soldiers, and so it's very exciting time for Edge. And again, I don't want to be the only one to speak, but the edge, you have to be very careful also. A lot of companies are talking about edge, but what is edge? If it's a big server that is in your factory, actually it's not the edge, it's a remote cloud. It's a piece of the cloud you've put in the factory. The edge, as per the Gartner definition, is where a signal is going to become a data. And where the signal, it could be any signal, it could be vibration, temperature, electromagnetic, whatever. When the signal becomes a data, at that specific location, that's the edge. That's the edge.
So
when you have a sensor on a machine, that's the edge.
We're running low on time. I'd like to say you made a cogent argument for machine learning. Is it an approach that you've taken as well at GFT?
Well, we didn't take the approach on the edge, actually, hearing what you've just said. So the whole the demo, but also the work we're doing behind that on data architectures is programmed in this case on Google Cloud Platform.
Yeah.
There's a machine learning component involved. It's on the Google Cloud Platform. It's not on the edge. So maybe next year we should come back and do the same thing and program it all on the edge. I think also I'm not technical, so I can't really judge exact
He's
decisions.
trying to sell you on stage.
Great, thank you very much. I'll give you mine later when I have my jacket. We do near real time analysis of the data. I think it all depends on the use case, like you said. In this case, the use case doesn't require the edge, but it'd be interesting to experiment, of course.
What's near real time for you? A millisecond, a microsecond, a second, 10 seconds?
I think it's a few seconds, but
okay.
The feedback is about how well you are driving, which you could use, for example, for insurance purposes.
Sure.
You don't need to know that in milliseconds, but a few seconds later in our dashboard you can see what's been happening. So that's the
And how's it take up from customers? Customers don't mind being tracked?
Well, the use case itself exists and has existed for some time. Especially in the UK and Italy, there's really also dedicated telematics providers that can provide something similar.
In the States as well, yeah.
In our case, what we're trying to show, this is the use case we've chosen to showcase what you can do. In terms of the platform, as I mentioned, we're working together with Google. This is also about how in the future the different operating systems, maybe in the car, providing information about the car and how you could maybe plug that in the future into different systems that either are provided by telematics providers or that a car manufacturing may want to have in its own environment. If it wants to do that in a modern way, then it would go through cloud. So of course, working with Google on this is really a play on looking how in the future in automobile, but possibly also beyond, you can provide these kind of build data architectures.
So I have to ask, I went to a presentation last week in which a senior executive from Rio Tinto talked about self-driving trucks in their open pit mines in Australia, in Western Australia. You have some competition out there. Are you worried about it?
As I said, this is a quite new market, and there are very few companies does that. And fortunately enough, Volvo is only announcing the development of their own tracks. So there are Caterpillar, there are Komatsu, and there are us who are implementing autonomous driving technologies in the open pits. So of course there is a competition, and we are fighting the battle with a very limited number of players currently. They are well established, as we are, but still it's quite limited. What will be next? I don't know. Volvo seems to be presenting very good product, though they have less credibility in open pit yet, rather than the companies like Komatsu, Caterpillar, and Zifra and its asset. We've been 30 years on the market already, and with solutions for digital mines. And this is autonomous trucks is the latest development. So first of all, of course, we will be presenting this technology for our existing account. As I mentioned, SUEC is Siberian coal company, is our existing customer for a long time already. They're using a huge variety of portfolio, and they've been one of the first who decided to implement autonomous truck on their side. But we have other customers globally of whom we will be pitching this technology for the next few years. So there is a competition, but in the same time we have existing accounts where we'll be offering this new technology to improve safety and mine operations.
So in the 7 minutes we have left, I think that's enough time to talk about, unless there's a question from the audience, there's enough time to talk about, there was another question, sir? No, just want to check your email. Caught you. Let's talk about the technology. We are at a technology-focused show, how IoT gets used. What technology were you able to take off the shelf, and what did you have to build yourself? Let's go left to right, starting with Zifra.
It's quite broad question because majority of the technology are well known, like computer visions and the processing of machine learning or from the sensors. So technologies are known, and it's the way how to use them, which engineers are implementing them, and the way you implement them. If we're speaking about AI game, this is the game about the data you have and the quality of the models you build around it. But the more data you have, you may have less qualified engineers to deploy the technology, to deploy the model. The more qualified engineers you have, you might have less data, and you will achieve the same result. The similar is the game of the machine learning and sensors and data analysis for autonomous vehicles. So the more qualified staff you have, the more experience you have, the shorter will be the lead time for developing these technologies and delivering this to the market. But technologies are available for pretty much everyone.
So, Joel, is that what you feel as well? I mean, were you able to take an ML engine off the shelf?
No, actually for us it was, I think, the opposite. We had to invent something that did not exist. Of course, we did not invent the mathematics. Mathematics have been here for quite a long time. Machine learning algorithms like KNN and so on, they do exist, but none of the solutions today available in the market are running inside a microcontroller. So our work for 3 years has been to rewrite from scratch every single algorithm so it can run inside the microcontroller. So that was a lot of work for our mathematicians and developers. So from a technology perspective, yeah, that was a lot of work. So again, we are we are very mathematic intensive company. We rely only on mathematicians, and then we have to apply that to the microcontroller world. So our technology is patented, but we could not leverage anything available on the market. We had to write everything. And now we have a development environment, which is called NanoEdge AI Studio, that we showcase here. And any developer without any knowledge in artificial intelligence can create a library, insert the library in his microcontroller, and will get instant access to machine learning capabilities embedded inside the microcontroller.
So let me ask the same question to GFT. Were you able to take any technology off the shelf, or did you have to build everything like Cartesian?
Well, actually, the interesting thing for us is that the challenge that was put to us by Google was, can we use the Google Cloud Platform to develop what we showcase here?
Why, they want more data?
Sorry?
They want more data.
Well, so what we show here, of course, doesn't use a lot of data. But what we are building is an architecture where you can process this for fleets of millions of vehicles. So there, I cannot go into the details, but there, of course, we are using the Google Cloud Platform, but we're also tinkering a little bit with the platform to make sure that some of the things that you need to be able to process larger amounts of data.
So you're finding you have to actually change the platform itself?
We we are tinkering with the configuration of a number of things. We're working together with Google on this to make sure that for this specific use case, especially if you look at largest amounts of data that you would have if you have bigger fleets of vehicles, that you'll be able to process it correctly through the cloud.
So based on your responses of three of you, I think the one who's taking the most off the shelf is yourself.
Yes.
Okay. So well, that seems to be an obvious question from the audience: is what were you able to use as is, and what did you have to build yourself? And I'm surprised that Cartesian had to build everything itself. Your job at Cifra was really one of integration. It sounds like.
Yes, it's integration, and it's the whole concept of equipment the truck with the sensors and all necessary equipment to make it autonomous. So it's a lot of work in optimization of the algorithms that allow us to make all this computation on the edge. Yeah, we're using edge computers inside trucks, and to make this possible to process all the data inside this huge truck and on the large and to communicate with the dispatcher center on the large distances. So this
what are the sensors on the truck out of interest? I mean, are there mostly cameras on the sensors, camera sensors, or there's also radar and sonar?
It's all type of. It's cameras, it's infrared, etc. It's similar technologies that I used for for your car, personal car. When you're parking, there is a distance sensors, etc. So all of that is used. Though, as I mentioned, it's a bit simpler task rather than having autonomous vehicles in the city, because there are less possible interference from the
no women with bicycles.
Yes, exactly. The worst can happen. I don't know, another truck that can appear on the path. But again, for that they have fleet management systems and the constant monitoring of the open pit to avoid these collisions. There are
any LiDAR out of interest? I mean, consumer products all have LiDAR except for Tesla. Is there anything spinning on top of the truck?
Of course, there are radars, lidars, all that.
There are. Okay.
Yes,
LiDAR,
yes,
sorry.
yes.
Yeah. Okay. You have one more chance to ask a question. We have 39 seconds left. You're all too tired. You want the keynote. I want the keynote too. Thank you very much, and congratulations to all of you.
Thank you.